Okay, B. Let's work through these. Find A and B if, and notice that that's the same as this but with an equal to, and remember that AM equals to GM when X equals to Y. The numbers that you're subbing into the AMGM are equal. Okay, so therefore the X and the Y is A over B and B over A, so we write A over B equal B over A. And solving this, A squared equal B squared, A equal B. Now notice I haven't put a plus minus, and the reason why is because we know that both A and B must be positive. I'm going to justify no plus minus by writing that. Okay, now that's a relationship between A and B. It's not actually the values of A and B. Convince yourself that as long as A equals B, this result will be true. Because if A equals to B, that becomes a 1 plus 1 is equal to 2, which is always true. So there's an infinite amount of answers where A equals B. Alright, moving on. We're going to do some applying AMGM questions now. And I've put some easy, quick examples. Well, one thing I'm going to say is often, even though AMGM is written like this, we often move the 2 over. Okay, so we often write it like that. It just helps us with a lot of questions. It's more useful to use this version of it. Alright. For positive real numbers A, B, C, use AM greater than or equal to GM. So I'm going to use this result here to prove. The first thing I see is I see two terms. So it's I'm going to use the AMGM for 2 numbers. Okay. So and I'm going to apply it 3 times and then it's multiplied, right? So I'm going to write A plus B is greater than or equal to 2 square root AB. Okay, B plus C greater than or equal to 2 square root BC, and C plus A greater than or equal to 2 square root CA. And because all these guys are positive, okay, because all these guys are greater than 0, we can times, okay? So 1 times 2 times 3, and we get A plus B, B plus C, C plus A, greater than or equal to, that'll be 2 cubed, which is 8. Okay, square root AB square root BC square root CA, and convince yourself that you got an A squared, a B squared, and a C squared there. Okay, which becomes the absolute value. However, because we know they're positive, we can drop the absolute value and we can just write greater than or equal to 8 ABC. Okay. I'll just rewrite this quickly. Okay. Next one. Let's try this one together. Alright. Well, the first thing I see is I see 3 numbers in a sum, and I see 3 numbers in a sum. So for this one, we're going to be using AM greater than or equal to GM for 3 numbers. Okay, so let's do that. So it'll be A plus B plus C. Now you could write on 3, but instead of doing that, I'm going to move the 3 straight away to the other side. So that's A plus B plus C. That would be like on 3. And then it's greater than or equal to the GM, which would be the cube root of the product ABC. Okay, so that's equation 1. Let's do it for 1 on A plus 1 on B plus 1 on C. It'll be 3 cube root of the product, and the product here of the 3 numbers is 1 on A, 1 on B, 1 on C. Okay, so let's call it 2, and we'll just do 1 times 2 here, and I think you'll see the result popping out pretty quick. 1 times 2. We've got A plus B plus C. 1 on A plus 1 on B plus 1 on C. That's the left hand side, greater than or equal to 3 times 3 is 9. I've got cube root of ABC, cube root of 1 on ABC, and then that cancels with that. We get the required result. Okay, I would rewrite the required result, but I'm going to move on for time's sake. Okay, here we go. Let A1, A2, all the way up to AN be positive real numbers such that the product is equal to 1. Use AM greater than or equal to GM to prove, and they've given us a result. So once again, it looks like I'm looking at a many product here. So there's 2 numbers, so I'm using the AM GM for 2. So that'll be 2 square root. That'll be 1 times A1, which if you simplify that, it'll just be 2 root A1. Okay, so similarly, second bracket would be 1 plus A2 greater than or equal to 2 square root A2, all the way up to a 1 plus A sub n greater than or equal to 2 square root A sub n. What we're going to do is we're going to multiply 1 times 2 times all the way up to n. What are we going to get? Well, we're going to get 1 plus A1, 1 plus A2, product 1 plus AN. Okay, greater than or equal to, you've got n equations, n factors of 2 here being multiplied, so that's 2 to the n. And you've got square root A1, A2, all the way up to AN. And we know that the product is equal to 1, so therefore this guy equals 1. And then you can see we've got the result. Okay, rewrite the same thing underneath. I'm going to be lazy there. Pretend you write out the full thing. Okay, let's move on and do some ones that are a bit tougher. You'll start to see how sometimes you need to be very thoughtful about how you approach these questions. And I'm going to try and tell you my thinking as we do these ones. These ones are a bit tougher. Here we go. Applying AM greater than or equal to GM on terms obtained after rearranging, I've said creatively. I'll try and explain my thinking as we go through. It's the most common way that AM GM is used. You have to be very careful with what you substitute. It can be tricky as it requires you to be innovative in selecting the terms to be used, and often questions involving symmetry require similar results in adding. Okay, here's a question. I see 3 terms added, so you might be thinking AM GM for 3, but there's a problem with that. That's what you would get if you use AM GM for 3 numbers. It's not very useful, right? It's not what we've got on the right hand side. Okay, so how would I know instantly looking at this not to use the AM GM for 3 numbers? Well, because what's happened to the powers is that they've gone from power 2 to power 1, and when you half the power, that's a good hint that you use AM GM for 2 numbers. If you want to cube root the power, use AM GM for 3 numbers. Okay, so the better way of approaching this is to notice that we can use AM GM for 2 numbers because the power is being halved. Okay, so what 2 numbers do I use? Well, maybe I just start off by considering a squared plus b squared. Okay, that'll be 2 square root, it's two numbers, a squared, b squared. So I've got a squared plus b squared is greater than or equal to 2ab. Now that should be familiar to you. We proved that a while ago. And by starting with a minus b all squared greater than or equal to 0, you can get that result. Alright, so now what we're going to do is we've got a result in 2 variables. We want to go to a similar result in 3 variables. So we do 3 pairs and add. Okay, remember that trick. If you've got 2 variables, you want to go to something similar, symmetrical result in 3 variables. You do 3 pairs and you add. So similarly, a squared plus c squared greater than or equal to 2ac, b squared plus c squared greater than or equal to 2bc. So add, and then when you add, we get that we 2a squared plus 2b squared plus 2c squared greater than or equal to 2ab plus 2ac plus 2bc, and then you can just divide by 2. Okay, take out a common factor of 2. And we get the result. Okay. That was a relatively simple one. Let's have a look at some more that are a little bit trickier. This looks quite similar. A little bit similar. For this one, what I'd be doing is I'd actually be looking over here at the product, and I'll let the product kind of guide me a little bit. What do I see? So if I bring the a squared, if I bring the a in the square root, that would be square root a squared b squared plus c squared, right? That's what that would be. So that kind of guides me. Maybe I'm using the 2 numbers a squared and the second number b squared plus c squared, because this is the product of the 2 numbers underneath here. So let's use am greater than or equal to gm with, if you like, x being a squared and y being b squared plus c squared, and let's see what happens. Okay, so we add a squared plus b squared plus c squared greater than or equal to 2 square root a squared b squared plus c squared. Okay, so we can just write that as a squared plus b squared plus c squared greater than or equal to 2a root b squared plus c squared. Okay, to get the second bracket, you can sort of see that it's going to be, the 2 numbers are going to be b squared and a squared plus c squared. We'll call it 1. So am greater than or equal to gm with x being b squared and y being a squared plus c squared. I think so we can do b squared plus a squared plus c squared greater than or equal to 2 root b squared a squared plus c squared. So we get a squared plus b squared plus c squared still greater than or equal to 2b square root a squared plus c squared, and that's equation 2, and then we can add that. Remember, we can always add left hand side and right hand side of inequalities if we've got the same sign in the middle. Okay, so you can convince yourself quickly that you're going to get 2 lots of a squared plus b squared plus c squared is equal to 2 lots of a root b squared plus c squared plus b root a squared plus c squared, and then the 2's divide, oh, that shouldn't be greater than or equal to, and then the 2's divide out and you get the required result. Okay, you would just rewrite the required result. Let's move on, next one. Alright, here we go. This one. Alright, well, having a look here. So we've got an interesting situation in that one of them has been one of the letters has been cubed root,